Hello and welcome back for another VMK in the game development series. In this VMK, we're going to continue on working with the texture class to enable us to load textures and texture our existing objects that we have in our 3D world. Now in our previous VMK, what we did is we created the NodeTexture class. This included the .h file and .cpp, and in there we had a function to load in a texture that was saved in a TGA file format. Now what we're going to do is we're going to go and modify the scene class so that we can take advantage of having this NodeTexture class. So let's get started. We want to go into our class view here and take a look at our scene. Here's our scene.h. We'll need to add some member functions here to take care of the textures, and we'll be doing all the loading for the texture inside the initialize function. So I'm going to just scroll down here to the bottom underneath the section where we added our last light. Yeah, right in here. Okay, let's take a look at what we're going to be doing here. We're going to create a local variable which is going to be a pointer to our node texture. And this pointer initially is not set to anything, so we need to go and call new, and we're going to pass into the constructor of NodeTexture our error handler pointer, which we already have in our scene class. If we get an error from calling this new, then we just generate an error message saying cannot create this new texture. We show the error message and then we just reset the error the same way that we did before inside the texture class. And then we'll just continue on as if nothing else happened. If this pointer is returned to us successfully, then we can go and call load texture, and we pass to this function a texture pointer as well as a file path. Now resources/texture/color test is the name of the file that we want to be loading. Let's go into Windows Explorer to take a look at this in a little bit more detail. As you can see here, this is where the game engine project resides on my computer. As you can remember, we've created these folders for the math library, object library, scene library, and then we had these other ones which we're using in the main section. Anytime we do a build, everything goes into this build directory under the debug folder. So here's our executable that we're building, and then here's the log file that we're generating, and there's the libraries that automatically get placed in here. So what I've done is I've created a resources folder, and inside there I've labeled another folder called textures. Other things that will go here could be sound, 3D models, things like that. You can just organize them nicely in this resource folder. So I've added textures, and inside textures I've placed this color test.tga file. If I open this color test.tga file in a program, you can see what this file looks like. All I've done is I've split it up so that I have a bunch of bands in different colors. The top band here is red, and then I have red fading to white and red fading to black. Then I do the same thing for green, blue, cyan, magenta, yellow, white. We have a pure white, a white fading to black, so we have grays, and then a black band. And then at the bottom here we have a rainbow of colors that are sort of fading to white. Now this is a little bit conceiving because in reality it's not fading to white. What I've done is when I created this file, I've actually assigned an alpha channel to this file so that we have an alpha effect. And if I go under layers here and take a look at the alpha channel, you'll notice in this little diagram here what the alpha channel looks like. So the top portion is completely opaque. It's colored white, which means it's completely opaque, which means in our OpenGL, if we go and render the top portion, it's going to look solid. You're not going to be able to see through it. But the bottom portion, which corresponds to this rainbow here, we go from a solid color on the left and we fade to basically transparent color. So this down here is going to be sort of translucent from the left all the way to completely transparent on the right. So keep that in mind whenever we go and load this texture into our program. So this is the texture file that we're going to be using. I'll include this inside the zip file that will be available for download. So you'll have a TGA file you can play with. You can go through any program that can generate graphics and create your own textures, create your own graphics, whatever you want. Just make sure you save it as a TGA file format. Okay, so back to our code now. We've initialized a pointer here. We create memory for it, and then we call loadTexture. Well, we have to go and write the function here for loadTexture, and we need to make sure that loadTexture is a function inside of our scene class. So let's go and do that. Inside scene.h, we need to add a member here under the private members. Inside the .h file, we'll add some functions here that we'll be using to interact with our textures. So the first one that we've already seen is this loadTexture, which needs a pointer to a NodeTexture as well as a file name that we want to load. This unsigned integer that it returns is going to be the unsigned integer which we can use to then select the texture when we need to down here. I'll talk about this a little bit later. After we load a texture, we need to make sure we have a function to delete textures from our memory. So I've created a function here called delete all textures. And then once we've loaded textures, we need to be able to select which texture we want to use whenever we go and render. So I've created two different functions here. We have select texture and select texture ID. Both of these functions do exactly the same thing, but the way they do it is slightly different. This select texture, you specify the file name of the texture you want to select, whereas this selection of the texture uses the ID, which is returned from loadTexture. You can do it either way, but I've done it two different ways to show you specifically the functionality behind the scenes. In a later VMK, I'll be showing you how to automate all this process so that you don't actually have to go into this code to make your program very robust. So in that process, we'll be using ID numbers. However, right now for testing, it makes more sense for us to work with the file names, so that's why I've created this select texture function here. You'll see how these two things are implemented in a second. In the same way we handle lights in our scene, we're going to handle our textures. So if we scroll down here into the member variables, you'll see that I created a STD vector of node light pointers that contain all of the light sources in our scene. Well, I'm going to do something very similar now for our node textures. The difference being is we're not going to be using STD vector. Instead, we're going to be using STD Map. And with STD Map, we pass in a file name as the first parameter, a pointer to a node texture as the second parameter, and then we have this texture compare structure here as the third parameter. And our member variable is going to be called MP textures. So this is going to be map pointer of textures. Now let me describe to you what a map is. It's similar to a vector in the sense that we can put data into the structure and it's going to be dynamic, so we can continue pushing data into the structure. However, the difference is instead of using numbers to specify which node light we want, so for instance here we always did m_lights square bracket and then a number to specify which light we want. With a map, we use a file name. So we use this first parameter here to associate which of these items we want to get from this map. That's basically how a map works. Now let's talk about this texture compare structure. We need to define how the map works to compare textures inside this structure. So for instance, if I say I want to be looking for image.tga, then map needs to know how to order its data internally so that it knows where to find image.tga. So we need to give this map a texture comparison structure. We can do that by going up to the top here under the structure section and defining that structure. And as you see here, we're going to do a texture compare with the bracket operator. And since our first parameter here is a constant pointer to a character, we need to have a comparison between character pointers. So we have one string value here and a second string value here. These are going to be our file names that we're comparing. We need to know which of these is going to be greater than the other. So to do that, we can just use the standard string comparison between S1 and S2. With the string comparison, we'll just return the value of this comparison less than 0 and pass that out. That's all we need to do for the texture comparison. So that sets up everything we need in scene.h. Now let's go into scene.cpp. Now let's go into scene.cpp and actually implement those functions that we're going to be using. Okay, if I scroll up here, I'll put the load texture right above initialize. Okay, what this function is going to do is add a texture to the scene and return the texture ID number. 0 is returned when there's an error loading the texture. So again, we pass in a pointer to the node texture as well as the string value for the file name that we want to load. If the texture pointer is null, we generate an error message and we just return. If it isn't null, then we continue on. Next thing we do is we check to see if the file name is valid. So we check the string length of the file name to see if it's less than or equal to 0. If it is, then we'll generate an error message. Otherwise, we'll continue on through. Now, don't forget that if this file name is invalid, what I'm going to do is delete our texture pointer that's passed in here. Since in our initialize, let me just place a marker here so I can find this quickly. In our initialize, which is down here, we created new memory using the new command here. After we call load texture, we want to make sure that this p texture up here has been deallocated because we don't want to go and deallocate it anywhere else. So we need to make sure we do that inside of our load texture function up here. So that's what we do here. Clean up the memory to the node texture pointer if there's an error message. Okay, then what we do is we create a local variable, an unsigned integer, which we're going to be using for the return value. This is going to represent the texture ID number if it's a successful load. If it's unsuccessful, we're just going to return 0. Next thing I do is I create a local copy of the file name. So I create a variable here, sz_file, and then using the new operator, I allocate enough memory to store the file name plus 1 for the null. I then copy the file name, which was passed into us, into this variable that we just created up above. I then convert that file name that we have in our local variable, and I convert it to be lowercase. Now, the reason why I do this is because in our map, I want to have all the file names to be in lowercase. This is very important because when a user chooses to load in another file, I don't want to be loading in the same file over and over. So for instance, if I have 4 objects, maybe I have 4 triangles, and all the triangles are going to be using image.tga as the texture, I don't want to load that texture multiple times into memory. I only need to load it in once and then refer to it using either the ID number or the file name. So after I convert the file name to be lowercase, I then go into our map of textures and I look for this file name, the lowercase file name. If I don't find the file name, then that means that this texture has not been loaded. So we need to go down here and we'll go and load it. If we do find it, then this texture has already been loaded into memory, so we can delete the pointer to this texture, which was passed into us, and we can go and return the value of the ID number to the texture that's stored inside the map. So what we do here is we go into the map and we extract the ID number from this map. Now remember, this map is going to store node texture pointers, so I can use this value in place of a node texture. And since every node texture has a member variable called UI ID, I can then go and just extract that data from the map and return it into our temporary variable here. Before we go and return that ID number, I want to make sure that I clear any memory that was allocated inside this function, which happened to be this file name. So that's what I do here using the safe delete. And then we just return. If we haven't loaded the texture yet, we'll then go and call the load function. Now remember, we created this load function previously in the last VMK, so just refer to it if you want to refresh your memory on what we do there. So I just pass in the file name of the texture that I want to load. If it loads successfully, it continues on down. If not, we do the cleanup again, and then this time we return 0 because an error has occurred. Down here we have a switch, and we check to see which render we're going to be using. If we're using OpenGL, we need to call createTexture OpenGL, and we pass to it the size of our map plus 1. So initially, our map is going to be size 0 since there's nothing stored in it. So the first time we load a texture, it's going to go through here, it's going to do all this stuff, it's going to load in the texture, and then it's going to call createTexture OpenGL. Texture map size is going to be 0, so we add 1 to it so that this value here is going to be 1, which means that our first texture that's going to get loaded is going to have an ID of 1. After loading the texture, using this OpenGL function, we then go and we need to save the texture data into our map. So to do that, we specify our texture map, we pass to this parameter here the file name, and then we can say that this map that we're specifying here is going to equal the pointer to this node texture. Our return value is going to be the texture ID, which gets assigned internally in here. And then after doing all that, we can then prepare our node texture pointer to be null. So in other words, we just clear it to be null so that we can go and call load texture again and load another texture immediately. This is just done as a little cleanup. We don't necessarily have to do this, but I do it anyway just to be sure. And we finally return the UI value, the unsigned integer return value. Now, remember, by doing this, I don't lose the pointer that's pointing to the memory for the texture. That pointer is already stored in this map. So if I ever need it in the future, I'll just use the map. Okay, so let's go take a look now at what createTexture OpenGL does, since we didn't describe that in the last VMK. Okay, inside createTexture OpenGL, we're going to put the following code. So first thing we need to do is save this ID number that we pass in here into our member variable. Then what we do is we enable textures to be used with OpenGL. So we call GL enable, and then we pass in GL texture 2D. We then select which texture we're going to be using so that we can set different parameters for this specific texture. So to do that, we call GL bind texture, GL texture 2D, and then we pass in the ID number that gets passed in here. This is going to say, I want to make this specific texture in the following way. And the things that we want to do is we want to specify whether we're going to be using mapping or filtering of the image. And then we're going to specify how we want to have the texture wrapped. So first thing is we're going to specify that the minimum filter and the maximum filter are going to be just set to nearest. So this means it's not really going to be using very much computation. As a matter of fact, it's going to be using very little computation to generate these textures. However, the quality of the images are not going to be ideal. So for instance, if we have a very small image and we stretch it over a large area, then it's going to look kind of sharp, you can say. It's not going to be very smooth. If we want to smooth it out, we can change GL nearest to GL linear. And then there's going to be filtering applied to this texture as it's being rendered in OpenGL. You can go into MSDN and take a look under GL texture param F for other kinds of filtering techniques that you can do. Other things that we do here is we specify the wrapping. Now, by default, we're going to specify to wrap both in the S and T direction, in other words in the X and Y direction, we're going to repeat the texture image. So if the size of the texture fills in the entire size of the object we put it on, then it's going to look okay. However, if the texture is smaller than the object that we're putting the texture on, then we need to decide what we do. So by default, I'm going to say just continue repeating the texture to fill in the entire size of the image. I'll show you how this works once we get objects rendering on the screen. We'll go and change this to be clamped to show you what exactly does clamped mean and what does repeat mean. Lastly, we need to go and load the texture data into the OpenGL memory. So in other words, we need to pass in all the pixel data into our graphics renderer. So it's going to try to store everything into our graphics memory. Now, this is very useful because then when we go and switch between different textures, it won't take very long time for it to render the different textures which are in the graphics memory. If the images are not in the graphics memory, then it's going to take some time for them to get transferred from regular memory into the graphics memory before they can be rendered on the screen. So we call GL texture image 2D and we pass in the following parameters. Now notice here we have a condition. If our type is equal to red, green, blue, then we pass in GL red, green, blue. However, if this is false, then we pass in GL red, green, blue, alpha. So in other words, this function here needs to know whether we're working with a red, green, blue channel or red, green, blue, alpha channel. We pass in the width and the height, and then again we have that same comparison, and we say that the data for the image, this is the pixel data containing all the red, green, blue, as well as alpha channels if they exist, and we need to specify in what order is this data specified, so we say here it's going to be an unsigned byte. And that's basically it. After this, our texture will be loaded into memory and basically ready to be used. Let's go back into our scene.cpp now. Okay, so that's our load texture function. If we go back into our initialize, I just want to refresh my memory here. So what we've done is we've created memory for this node texture and we've loaded it into our graphics processor. Now, before we quit our program, we need to call our function delete all textures so that we can deallocate the memory that we've just created. So let's go and do that now. If we take a look at the destructor for our scene, we'll call clear all anytime we need to deallocate memory for objects. So let's take a look at clear all. And under clear all we have this section here, delete all lights. So we're going to replace this now with the following. We're going to get rid of the lights and the textures in the scene. So we're going to call delete all lights, same as we did before, but now we're also going to call delete all textures. So let's go and write this function delete all textures. I'll put this delete all textures function right underneath delete all lights. So here's delete all lights. Actually no, I'm going to group it in with the texture stuff. So I'll actually put it right underneath load texture. Again, you can put it anywhere you like, it really doesn't matter. I'm just trying to group things that seem logical to myself. So here we go. Here's delete all textures. What we need to do is we go through the entire map which contains all of our pointers to the data that we've loaded. And the way we do this is we create an STD Map iterator which is going to start off at the very beginning of this texture map. We're going to use this iterator to go through the entire contents of this map until we reach the end of the texture map. And we're going to increment the iterator by 1 every time through this loop. And every time inside the loop, this for loop, we're going to call delete it second. This in effect will be the same thing as calling delete texture, where texture is our node texture pointer. Now remember, in our map we've stored our node texture, but to extract data from our map we need to use this iterator. So if we want to refer to the node texture, we need to refer to it using this pointer to the second item, which happens to be node texture. So we just call delete on that. And then we also call delete array it first. This is in effect the same thing as calling safe delete array on the file name. Since we allocated memory for us to use to store the file name, we need to delete that as well. So we do both. We delete the node texture pointer as well as the memory that was stored for the file name. So we go through all that, we delete everything in our map, and then after that we go and call clear to clear all the values that were stored in the texture. And that's all for delete all textures. Okay, there's only one other thing we need to change inside of our scene class, and that's our update. So let's go into update and take a look at here. Here we go and render everything to the screen. So we're calling our ground, which is our flat grid, and we call render. We have our house and we call render, as well as we had this window which was a triangle and we call render. Well, we're going to modify each of these classes by changing the render function. And the way we're going to do this is we're going to change it so that the render accepts a Boolean value, either true or false. If it's true, then that means we want to use a texture. If it's false, then that means we don't want to use a texture. So just continue on doing exactly the same thing that it's doing right now. Now, when we do select to use a texture, we need to be able to select which texture we're going to be using. So that's where we have the select texture ID as well as the select texture functions that we're going to be writing next. So for instance, in our initialization, let's go back to our initialization here. Here we go and create a texture that we store inside of a texture node, and then we store inside a map. If we were to save the value that load texture returns here, it should be 1, which means that this first texture, color test, would have an ID value of 1. Knowing that, I can then go inside this render and call select texture ID and then pass in 1. This means that I'm going to render the ground with the texture for the color test.tga file. Another way to do the exact same thing would be as follows. I would just call select texture and then specify resources, textures, color test.tga. Now, to a human, this is more understandable because we can see, okay, I want to render the ground by selecting the texture called color test.tga. So this is very easy to debug. However, when we automate, the computer doesn't need to know things by file names. It can work with IDs just perfectly well. So we're going to be actually using this whenever we start automating things. However, initially, whenever we're debugging, I'm just going to be using select texture as follows by using the file name. Okay, let's go and write the select texture ID as well as the select texture function so that you can see what they do. Okay, I'm going to put both of these select texture functions right above load texture. And I just noticed a bug here. This should be written as load texture, not add texture. Okay, so right above here, let's take a look at our select texture function first. So with select texture, we pass in a file name. And the file name that we pass in should be a valid file name which we already loaded. First thing we do is we take this file name and we check to see if it's valid. So we take the string length of the file name and check to see if it's less than or equal to 0. If it's not less than or equal to 0, then we continue on through. If it is, then we just return false, which means we're not going to be using a texture. We then create a local copy of this file name the same way we did earlier. So we create some memory and then we copy the file name into this local variable. We convert that local variable into lowercase, and then depending on which graphics renderer we're using, OpenGL for us, we're going to go and look for that specific file name inside of our map. If we find it, we continue on down here. If we don't find it, then that means that the texture hasn't been loaded yet. So what we can do is we can disable textures by calling GL disable GL texture 2D, and then we'll we can safely delete the memory that was allocated up here. And then just return false to say we're not going to be using a texture. Next thing we do is we enable textures, since we want to be using textures now, since we have a texture inside of our texture map that matches the file name that we specified in this function. So we go and extract the number of bits per pixel inside the map. If it's 32, we turn on blending. If it's not 32, then we turn off blending. So in other words, alpha blending has to be turned on, or else the texture won't be rendered correctly on the screen. In other words, you won't be able to see through it. If there is 32 bits, we know we have an alpha channel, so we have to turn on blending. And the last thing we do is we select which texture we want to use. And to do that, we call GL bind texture in the same way we did earlier. And this time, we're passing into it the ID number of the texture that we want to use. So the texture is the one that we found here using the file name, and we use the ID number that's inside that NodeTexture. Last thing we need to do is just delete the memory that we've allocated here for the file name. So we call safe delete array, and then we return true, saying we did find the texture that we wanted to load, and we're actually going to use it since we called GL bind texture up here. The same functionality can be done using the select texture ID. However, this is actually a little bit simpler since we don't have to be doing searches inside of our texture map. First thing we do is we decide how to handle the different kinds of renderers. We're going to be using OpenGL, so that's the only one in here for now. We check to see if the ID number that was passed in here is valid, so it has to be not less than or equal to 0, or it cannot be greater than the size of the texture map. If it is one of these cases, then we'll just call GL disable and return false to say that we're not going to be using textures. Otherwise, we go into our map of textures using the iterator, and then we continue moving this iterator until we get to the ID number that was specified inside this function. So after this for loop, we now have our iterator pointing to the correct texture in our map. We call GL enable since we want to be using textures, and we check to see whether the number of bits per pixels is equal to 32. If it is, again, we have to turn on blending, otherwise we'll turn off blending. Lastly, we call GL bind texture for the ID number of the texture that we want to be using. And the ID number, again, is the value that gets passed into this function. And that's basically it. We return true to say that we're going to be using a texture with the specific item that we want to render. Well, let's save this now, and let's see if we can build it. We're going to get some building errors since all of our render functions don't accept booleans, but we're forcing them upon them right now. Okay, we're getting an error here saying NodeTexture is undefined, and that's primarily because we didn't go up here and include NodeTexture.h. Let's save that and rebuild. Okay, the compiler doesn't know what a map is, so we need to go inside our standard stdafx.h and include it. I'll do it right here above the vector part. And let's try rebuilding again. Okay, that's looking better. Now you'll notice that we're getting these errors here with the render because select texture is returning a boolean, but this render is not expecting any parameters to be passed into it. So in the next VMK, what we're going to do is we're going to go in and modify the render function calls for our flat grid, our triangle, as well as our house, so that we can then go and render textures.